Hello, my name is Beth Stivey and I'm here to talk to you today about a few of the things that I think about when I'm planning to teach converting fractions, decimals and percentages. Now this video is split into four. We've got the big ideas for part one, which is what is this topic even all about? What are the key things we need to be teaching? Part two is the prerequisites. What topics do we need to make sure our students are really confident with before we start teaching this topic? Part three is the key teaching aspects. So that's key representations I like to use, key ways into the different areas of this topic, and some nice resources that I like to use as well. And part four is talking about why is this even important? Where is this topic going to lead to in the rest of Key Stage 3 and also onto Key Stage 4? So to start with, we've got some big ideas. So the four big ideas I think linked to this topic are understanding that fractions, decimals and percentages are different ways of expressing proportion. This is quite a tricky one for students to fully grasp. They often see fractions, decimals and percentages as separate entities, and so the idea of them being different ways of expressing the same thing often throws the students. So that's something that I really want to embed in Key Stage 3 and I think is really important to make sure the students fully understand. The next three are three things that if they understand these three, they should be able to fluently convert between a fraction, decimal, or percentage of any size without any problems. So the first one is understanding the meaning of place value headings. Often they understand what the place value headings are, they know what the names of them are, but they don't have a full understanding of what tenths are, what it means to be a tenth, what a hundredth is, and particularly on the right-hand side of the decimal point. An understanding of the word percentage and what it means, and also an ability to find equivalent fractions. And an understanding of what a fraction represents and what the line of the fraction represents. Again, this one's another really hard one for students in Key Stage 3 because a lot of their primary school education has looked at fractions as parts of a whole because that's what it is. But we're then trying to get them to think about fractions as a division. So 3 out of 4, 3/4 is 3 parts of 4. But also 3/4 means 3 divided by 4, and that's a really hard transition for students to make. It's a difficult concept for them to grasp. There is a really nice task in the supporting document that you might want to have a look at that I sometimes use to really support the students with this, looking at having 3 sandwiches and splitting it between 4 people, and it just gets them thinking about fractions as a division as well as parts of a whole. So some things that students often find challenging. So I've split this into things that they find challenging and then the kind of misconceptions you might see in lesson time. So converting fractions to decimals, they don't recognise fractions as a representation of division. So that's what I was just talking about, that task. Converting decimals to fractions and a lack of familiarity of the understanding of place value headings. So again, what do those place value headings actually mean? Converting fractions to percentages when the denominator is not a factor of 100. So when that denominator is an awkward number, the students often can't get from the fraction to the percentage because they can't see how something like 15 can get into 100, and they don't have the fluency or the flexibility to be able to find a way around that. And then converting fractions, decimals and percentages greater than 1 often throws the students. As soon as it's over 100% or over 1, it really just baffles them and they get really confused with that. And then the types of mistakes that they make, there are loads of mistakes that can be made here. These are just a few, and very similar mistakes are made across the board. So thinking things like 0.4 is 4%, often it comes from not having a good understanding of the place value headings. Thinking that you can't have a decimal and a percentage. Again, thinking of these as very two separate entities and not understanding that you can still have a decimal percentage and what that actually means and what it means to have 0.5 of a percent. And thinking things like 3/4 is 34%. They often take the numbers from a fraction and just throw it into a decimal or percentage because they don't have the full underlying understanding of this topic. And if you choose questions carefully, the students can dispel these misconceptions themselves. It's not something that you necessarily need to tell them about, but you can discuss it while being drawn out of questions that expose these misconceptions. Okay, so from Key Stage 2, the students have an extensive understanding or kind of experience with fractions, decimals and percentages, but largely as separate entities in Key Stage 2. They are expected to convert, but a lot of their understanding relies on a memory of certain fractions, decimals and percentages that they know to convert. So, for example, a half or maybe a quarter, sometimes a tenth, they will have a memory of this rather than necessarily an understanding. So one thing I like to do to establish that is to ask them to see what fractions, decimals and percentages they can convert, and then say, okay, can you explain to me why? And then you can see where the gap is and what we need to do. So they have got a lot of experience of all three separate entities, and we need to start looking at how we can move away from the reliance of a memory and more an understanding. One other thing that's really is in the Key Stage 2 curriculum is this understanding of fractions, decimals and percentages being different expressions, ways of expressing proportion. So that is brought into Key Stage 2 and they should have an understanding of it, but often, again, it relies on memory and they haven't had enough experience of it yet to fully embed that concept. So some topics to consider teaching before covering this topic. There are quite a few, and a lot of them, all of them, they will have seen in Key Stage 2. So at this point, I would choose a few tasks just to identify how confident they are with each of these topics. And the three I starred are three that are absolutely fundamental. If they can't find equivalent fractions, if they don't know what the place value headings are or what they mean in both integers and decimals, and if they can't multiply or divide by powers of 10, then they actually can't do the conversions at all. The others, a confidence with them will support them in moving into this topic. So I tend to spend some time on all of these and choose some topics. And the following slides are going to be some tasks that I use to establish what they can and can't do and what their confidence is with each of these topics. So the first one is a variation theory resource. So it's looking at intelligent practice, just converting, finding equivalent fractions. One thing to note is that the title of this task, I would be tempted to change the title. So it says, what if we multiplied by to make the equivalent fraction? I would be tempted to change that to what if we multiply the numerator and the denominator by, because ultimately we're multiplying by 1 in each case to make sure that the fraction is equivalent. So that's just a wording thing that is part of the task, and I would just change it, or at least discuss it with the students so that they are happy that they're not multiplying by 2 or 3 or 4. They are always multiplying by 1, but they're multiplying the numerator and the denominator by a certain number to make the equivalent fraction. And the task on the right is a maths pad resource. Both of these are just snippets of the full resource, but I really like that one on the right because it shows different representations. So the students then are looking at fractions, decimals, percentages as a number on a number line, as a shaded in image, as a fraction. So I like to try and bring in as many representations as I can along the way to just familiarise the students with the different ways you can represent fractions, decimals and percentages. Okay, this one is a really nice resource to get them understanding the place value headings and making sure they are happy with them all. One thing I would do with this resource is I would just make sure that I would ask the students to verbalise what it is that they've done to solve this question. I would ask them to either explain to themselves, write a sentence, talk to me about it, just so that I can draw out exactly what their understanding is, rather than just guessing or not having a full understanding of what the different place value headings mean. And last one, again, this is a nice one to draw out their understanding, and it kind of combines a couple of different topics in terms of adding and subtracting. But it's just a nice resource that I like to use. This one is a median DON resource, and it can be adapted. It's quite a nice one to be adapted. You can change it to percentages, fractions, whatever you like. And it gets the students thinking about ordering numbers, and it draws out misconceptions of percentages can be put on a number line. So it's just a really nice resource to really get the students thinking. And the last couple of resources, we've got some multiplying and dividing by powers of 10, an intelligence practice question, which is on Maths Box. So intelligence practice questions can be found on Maths Box, variation theory. And one thing with intelligence practice is, if you haven't heard of it before, it's where each question is slightly different. One thing is changed from the previous question. And it really gets the students unpicking what exactly is going on, and gives them a more of an understanding. But the danger with intelligent practice questions is the students might not realise that that's what you're trying to do. So with these kind of questions, as you can see, the numbers, so the dividing by 10, dividing by 100, small things are changing each time. I would encourage them to think about what the difference is between the current question and the one before, and why that has changed the answer and what is happening. Rather than just doing the question, I would get them really thinking about what's going on in each case, because that is when they have the better understanding. That their ability to verbalise what is going on in each question and why the answer has changed and what has happened encourages them to fully understand what it is that they're doing, rather than blindly doing the question. Okay, so we're moving on to the third part of this video, and that's the key teaching aspects. Having done all of those kind of prerequisites, checking the different areas of what the students can and can't do and what their gaps are and what their understanding is, I then move into the actual topic in hand. So what they need to know at Key Stage 3 is to be able to work interchangeably between terminating decimals, fractions and percentages, and also understanding what percentage means as numbers of parts per 100. So once that's what they need to be able to do, I always start every topic with some keywords. There is a huge number of key terms which is brought into this topic, most of which they will have already seen in primary school, but it is essential that the students are comfortable to use them throughout this topic. So I like to get the students to talk about what it is that they're doing. I like them to use the keywords, so that's why it's really important to make sure they're shown at the beginning of the video, of the lesson, and talk about them, make sure the students are happy with them. One thing that I really like to highlight here is digits. Digits is a really funny one. Students often don't fully understand the difference between digits and numbers, and so that's something I like to talk about at the beginning of this topic, just so they know that if I'm talking about a digit in a number, they know exactly what that means. And I also bring in these keywords regularly during the lesson, just to make sure that they're happy with them and make sure that they are getting more and more familiar and more confident with talking mathematically. So it is very tempting in this topic, and I have definitely done this before, and I will not be doing it again, to give the students an image like this one on the screen, and fill in the different sections of how to get from fractions to decimals and decimals to fractions and percentages to fractions and fractions to percentages. Fill the grid in, or the image in, ask them to copy it into their books, and then get them to do some practice questions. It's very tempting to do that, and I would really encourage you to not do that, not yet anyway. While that resource is useful and that image is useful, it's very much, it doesn't give the students an understanding. It's just a rote learning. They're just looking at something, this is how you do it, and then they have to try and memorise that to get to be able to do the questions. And the beauty with fractions, decimals and percentages is it shouldn't rely on memory. They can work these out if they have an understanding, and so I would really encourage you with this topic to teach for understanding rather than memory. And the only way to do that is to look at each conversion individually. So look at fractions to percentages, look at decimals to percentages, look at fractions to decimals. Individually, spend time on each one individually to make sure they fully understand that conversion. So it's something that I like to come back to, this triangle, at the end of the topic, but the students can fill it in themselves, not me giving them the information that they then have to regurgitate. If they fully understand what I've taught them, they should be able to fill in this triangle on their own without any input from me. So I start this topic with a 100s grid. I like to print these out and laminate them, and then the students can use them kind of throughout the series of lessons that we're doing these conversions. They're particularly useful for fractions to percentages. And what I tend to do is I ask the students to shade, for example, 1/4 of this grid. I start with 1/4 because visually it's very easy for the students to see, and often they can split the grid into quarters quite easily, and they can shade it in. I then say, okay, well, how else can you describe the fraction that you shaded? Now, it might be at this point that they've spotted that there are 25 squares shaded in and 100 altogether. A couple of students might spot that a 1/4 is 25% instantly, but whether they will be able to understand to explain that to you, and that's where this grid comes in. We've got 25 little squares out of 100, so 25 out of 100, and that's 25%. And highlighting the fact that percent means out of 100. From there, I then look at different fractions, maybe a fifth, maybe 6/10, 3/20, whatever really. You can really play about with this. The limitation with this resource, though, is that you do need to be using the denominator has to be a factor of 100 to make it kind of usable for the students. There is a limit to this resource, but it certainly gets them thinking about percent meaning out of 100 and how that relates to the simplified fraction of 1/4 or whatever you're using. I also like to look at numbers greater than 1. So I might go for something like 1 2/10. And the students will then realise that they need more than 100 grid in order to shade this in, because one full shaded in grid would be one whole, and then the 1/4. So percentages to fractions, again, I'm still using the 100 grid, but I ask them to shade percentages and see if they can write them as fractions, drawing out the idea of percentages being out of 100, and then we look to simplify where possible. If the students are, so I might start with something like shading 60% of this grid. If the students are really struggling with this, I might break it down into, okay, let's see if we can just shade 10%, 10 out of 100. What's 10%? Okay, what's 20%? What's 30%? Building up to what's 60%. Or I might say, what's 10%? Okay, what's 50%? So what's 60%? That's the 10% plus the 50%. So some students might need that scaffolding. And again, just highlighting making sure the students are happy that percent means out of 100. You could also talk about the history of where that comes from and what language that comes from, just to kind of hook the students. It's quite a nice one to think about. So the next few slides are some resources I like to use when converting between fractions and percentages and getting the students to get some practice of this. These examples are intelligence practice again. And I really like that they use numbers greater than 100% and decimals as well, decimal percentages, which is often something that students really struggle with. And it really allows the students to challenge their own understanding and exposure to these kind of slightly weird questions, as it were, really gets the students to dispel the misconceptions themselves, rather than sticking with whole numbers or percentages less than 100%. This one, if they've fully understood everything up to this point, they should be able to dispel these misconceptions themselves. And this resource by Median Don is another really nice one that uses adding and subtracting, and they have to convert the fraction or the percentage before they can do the calculation. All of these fractions have denominators which are factors of 100, so the representation using the 100 grid will work nicely with these if they are needing some extra scaffolding or support when they're converting these. So moving on to decimals to percentages, this one is arguably an easier one that students can get from one to the other quite quickly, but whether they have a full understanding of why is where they fall down. And I think the best way to kind of give them that understanding and allow them to familiarise themselves with that understanding is again using a 100 grid, but this time if the image represented 1. So I really do spend some time on this one. I make sure that the students are happy with, if the whole grid represents 1, what does each little square represent? We've got 100 of those squares all together, so each one of those squares is 1/100th. And how can we write that as a decimal? And so really getting the students familiar with this representation. And then also, what does each column represent? And once they're happy with that, I then spend some time just with this one grid. I don't talk about percentages really at all until I'm happy that they have fully understood this representation. I ask them to shade in, okay, well, if the whole thing is 1 and each square represents 100, so 0.01, and each column represents 1/10, so that's 0.1, how could we shade in 0.37, for example? Or how could we shade in 0.02? And how is 0.02 different from 0.2, for example? And so really kind of getting to grips with the students, getting to grips with what this representation is, and how they can manipulate it and how they can represent different numbers using this grid. How could they possibly represent 1.2 or 1.47 or something like that? I might even give them something really quite tricky like, how could you represent 0.005? How could you represent 5 thousandths? And is that even possible on this grid? And why is it challenging? And what would we have to do? And just drawing out a really deep understanding of this visual representation for decimals. Once I'm confident that they've had a go at shading themselves, I would then maybe give them some shaded regions and ask them to say, well, what does this shaded area represent? Again, familiarising themselves with the representation. Once I'm completely confident that they are happy with this representation, going from either shaded to a decimal or decimal to a shaded, I would then give them 2 grids. And I'd say, okay, well, what happens if we shade 30% of the 100 grid, and then shade exactly the same on the 1 grid? And how could we represent that using a number? What number is shaded in? What proportion is shaded in as a decimal? And we've got what proportion is shaded in as a percentage and what proportion is shaded in as a decimal. And once we're happy with those, with lots and lots of examples, the students may, after a few examples, it might take quite a few, but after a few examples, hopefully the students will be able to spot how to get from one to the other. They might be able to make some predictions of how to get from decimals to the percentages or percentages to the decimals, with more of an understanding of why and where these numbers have come from. And it's not until once they've made some predictions, I might ask them to write down some predictions or talk to the person next to them about these predictions. I would then give them this image of percentages and decimals and how we get from one to the other. So dividing by 100 to get from percentages to decimals and multiplying by 100 to get from decimals to percentages. And then this is something that I would ask them to copy into their books with a couple of examples as their notes. Again, some examples of resources I would use using intelligence practice. And also I like to use a number line here because percentages on a number line, students often can't visualise it. They're not happy with it. It doesn't sit well with them because they're not familiar with it. So this is a nice opportunity to get them familiar with it and get them realising that percentages are another way of expressing a proportion in the same way decimals are another way of expressing a proportion, and fractions are the same. So I do really like to use number lines often when converting fractions, decimals and percentages. And also these questions are really nice as they go over 100 and go over greater than 1. So familiarising the students again with that greater than 1 idea. Okay, the last kind of conversion that we need to talk about is the fractions to decimals. This one is a less intuitive method for students because they often are not familiar or not happy with, or they forget what the line of a fraction actually means. So I start with spending some time converting fractions to percentages, going fractions to decimals, going via percentages, because they're happy with that. They've got all the skills up to this point. They've got all the skills to get from a fraction to a percentage and a percentage to a decimal. So there's no reason why, even if they can't get straight from fractions to decimals yet, they should be able to get from fractions to decimals using the methods that they've got so far in their arsenal. They should be able to have some flexibility here, and if they can't get from one to the other, they can actually use the manipulation that they know already. So I'm starting with a half because it's something that they should be really familiar with, and I like to start with something that they are really confident with and challenge their understanding of why, because they're very happy that on 1/2 is the same as 50% and that's the same as 0.5, but whether they can explain why is another story, and that's why I like to start with it, because it really challenges them to think about the why rather than the actual process of doing it. So 1/2, hopefully they're happy by this point to get to 50 over 100, which is 50%. And then again, hopefully using the skills they've learned so far and what they're familiar with so far, they can then say, well, that's 0.5. Once I'm happy with that, I tend to ask them to think about looking at an alternate method. Can we find another way of getting from 1/2 to 0.5 without using this middle step? Now, it might be that some students are already familiar with what the line of a fraction means. And if they're not, and hopefully if you've used the sandwich task from the beginning of this video, then they might well have a good understanding of what that line of a fraction means. But if they haven't, then I'd give them something like this, quite a challenging question, 3/7. The reason this is challenging is because the 7th, the denominator, is not a factor of 100. So they're going to struggle trying to get this to a percentage to start with. So we then talk about this, the fact that this line actually represents a divide. So we could say, well, this means this is the same as, it's equivalent as 3 divided by 7. And what is 3 divided by 7? Using a calculator or a long division method, whatever you like. They should get to, now this is an awkward number, but they should get to a decimal. And so we've got from a fraction to a decimal, using the understanding that this line actually means divide. And what I really like to show them next is this visual, where we've got a division sign, and they hopefully should understand by the end of your teaching episode that actually this division sign literally means a fraction. We've got a number, the numerator, the line meaning divide, and then another number. That's where the division symbol comes from. And if they have an understanding of that, then hopefully they'll remember that and be familiar with being able to get from a fraction to a decimal just by dividing the numerator by the denominator. And then moving from decimals to fractions. So when I'm doing decimals to fractions, it's really key that they are happy with what the place value headings mean. So I start with something like 0.2. I don't choose 0.1 because it's something that they might already know by memory. They might just know it straight away. This one I want them to potentially not know it from memory and see if we can draw it out from them. So we started with 0.2 and I ask, okay, what different ways are there of saying this? It might be that I have to give them a bit of a hint, and my hint would be, okay, think about place value headings. What place value is the 2 in? And hopefully then we get to, okay, well, that's 2/10, and 2/10 is 2/10, 2 out of 2 over 10. And so we've got from a decimal to a fraction quite nicely there. I then might give them something like 0.23. Again, this is a little bit trickier because you've got, well, 2/10, but then you've also got 300. So how can we combine them? And we need to use some equivalent fractions here to say, well, that means the 2/10 can be written as 20 hundredths. So we've got 23 hundredths in total. And with some questions, this one is not an example, but in some cases you can then simplify the fraction to get it to a nice, more simple fraction. I might also look at numbers over 100. So again, how can we, numbers greater than 1, how can we write 1.25 as a fraction? So we've got 1 whole and 25 hundredths, which can be simplified to 1 1/4. I might also give questions like 0.07 or just manipulating and getting them to think about the phrase, how can we say this in a different way? This 0.07, how can we say that in a different way? What does this mean? And from there, we can draw out the fraction, because actually if they understand what the place value headings mean, they should be able to create the fraction themselves without having to rely on a memory of various, some that they might already know, like 0.5. So some examples that I like to, of resources I like to use, these are all taken from White Rose. They're just the example questions from their free scheme of work. And a lot of them are using tenths and hundredths, but I often give the students similar questions with more challenging denominators. But they're just quite nice representations with the bar models, with number lines again, with using these inequality symbols, just drawing kind of overlapping different topics that they would have seen in other areas of maths and drawing it into this topic. So these are all quite nice ones that I like to use. So the last kind of bit that I want to talk about in terms of the teaching episodes is where they've got a question like this, where we've got 5/8 and we're trying to convert it to a percentage. Now, if we're using the skills that we've looked at with fractions to percentages, this is really tricky because the denominator is not a factor of 100. So that 100 grid is not going to help us a huge amount in this case. So in this case, I would really like you to, or I tend to encourage the students to think flexibly, be flexible, and remember that these fractions, decimals, or percentages are all different ways of expressing proportions. So we can express the same number as a fraction, as a decimal, or as a percentage. So we don't have to go straight from fractions to percentages. We can go from fractions, in this case, from fractions to decimals. Can we convert it to a decimal first? And then from a decimal, we can get to a percentage. So if we encourage flexibility between these three entities, then they should be able to convert anything, even if they have forgotten how to get from a fraction to percentage, or if it's a tricky one, they should be able to get around it by finding another way to do it. So in this case, they can convert 5/8 to a decimal by doing 5 divided by 8, and then multiplying the answer by 100 to give us 62.5%. So encouraging that flexibility really does deepen the students' understanding, and it gives them the confidence to realise that a lot of these things don't rely on memory, and if they have an understanding, then they can work things out. And I think that often takes the pressure off students, because if it's constantly relying on memory and they're struggling with their memory, or they've got difficult with their working memory, they find it difficult, then this kind of helps them realise that they don't need to memorise everything. And it's actually impossible to memorise everything, certainly in fractions, decimals, and percentages. So you can work it out, and there's always ways around it, and you can use what you know to get to where you need to be. So to finish off, I've just got a couple of resources that I like to use once I've covered fractions, decimals, and percentages conversions, just to kind of assess what they know, what they can and can't do. So these are 3 resources, 2 from MathsPad and 1 from the Standards Units resource. I really like kind of matching tasks, odd one outs, because it identifies misconceptions, it challenges their understanding, it just gets the students really thinking about what it is they're doing rather than just working through a set of questions. And it's at this point then that I potentially look at one of these images that I showed at the beginning of the video, where the students have to create their poster or whatever to explain how to convert from one to the other. If they have a good understanding of how to do this, then they should be able to fill this grid in with this image in with no problems, either verbally or written. It's up to you, but I quite like giving this as a task at the end of the topic to assess whether the students actually are happy with manipulating between the three different proportions. And then I like also to give these explain why tasks, explain why questions. It gives is a great opportunity to assess and monitor the students' understanding. Mathematical discussion and the ability to verbalise explanations does really require a deep understanding. And if the students can do that, and if they can draw out misconceptions themselves, then they've mastered a topic. If they can explain why, then they've mastered the topic. And so I really like to finish off with some of these questions as well. And so part 4 of this video, just a little bit on why is this important. Fractions, decimals, and percentages can come up in any topic, shape, probability, loads of different topics. But these are some of the ones that I think are really pertinent. They come up quite a lot in these topics. So percentages of amounts using multipliers, compound interest and reverse percentages, fractions of amounts, calculating with fractions, decimals and percentages, which we saw a little bit of earlier, recurring decimals and to fractions, which is something they see in Key Stage 4, and probability. But also, like I said, actually it can come up in anywhere, any topic, in the context of any topic. And so it's really, really important that we get it right in Key Stage 3. Thank you very much for listening. Bye-bye.